Now let's talk about what is a circle. A circle is this shape here, and the most important point in this shape is the center, this point. In fact, the defining property of the circle is that if you take any point from the circle and you connect it with the center of the circle, then this length is going to stay constant no matter which point you choose on the circle. So you could have chosen the point here and the length would still be the same. You could have chosen the point here and this would still be the same length. And so all the 6 lengths that I've marked on the picture are equal to one another. This length is called the radius of the circle, and we're going to denote it by small r. Sometimes we're going to denote it by big R. A chord in the circle is a segment such that both endpoints of the segment lie on the circle. Obviously, chords can be arbitrarily small, but what's the largest chord a circle can have? It turns out this is the chord that passes through the center of the circle. It has a length of 2r. A chord that passes through the center of the circle is called a diameter of the circle. Then, the center of the circle is always the midpoint of any diameter. Notice that each chord in the circle splits it into 2 arcs, one small arc and one large arc. The diameter also splits the circle into 2 parts, but this time the 2 arcs are equal. Notice how each arc in the circle corresponds to an angle. For example, this blue arc here, defined by this chord, corresponds to this angle in the circle. The angle defined by one of the endpoints of the chord, the center of the circle, and the other endpoint of the chord. But now, this same chord defines another arc in the circle, this large blue arc, and it corresponds to this angle right here. So, each chord splits the circle into 2 arcs. One of the arcs corresponds to an angle, and the other arc corresponds to another angle. And the sum of the 2 angles is always 360 degrees, as you can see in the picture here. A diameter in the circle defines 2 arcs that are equal. This arc is equal to this arc. The 2 angles that correspond to the 2 arcs are this angle and this angle. Since the arcs are equal, then the angles that they correspond to should also be equal. But the sum of the 2 angles is 360 degrees, and therefore the angles here and here must be 180 degrees each. Which is of course obvious from the fact that this is a straight line and 180 degrees is a straight angle. And so any diameter in the circle always defines an arc which corresponds to the angle 180 degrees. This is the optional problem. We have that this point is the center of this circle, and we have that this point is the center of this circle. We also know that this circle passes through this center, and this circle passes through the other center. We intersected the 2 circles at this point and this point, and we need to prove that the 5 segments marked in red are all equal to one another. And here's the solution. This point, and this point lie on this circle which has this point as its center. And therefore, this length equals this length equals this length equals the radius of this circle. Similarly, this point, and this point lie on this circle which has its center right here, and therefore this length equals this length equals this length equals the radius of this circle. But now notice that this length has been the radius of both circles, and therefore both circles have equal radii. And so all the segments marked like this are equal to all the segments marked like this. And so all the 5 segments must be equal to one another.